All right, Unit 8, Day 3, getting into solving equations with radicals now, okay? So, with these, a radical equation contains one or more radicals, okay? To solve an equation that has a radical, we're going to look at a few different types here. Most basic ones are ones that only have one radical in them, all right? So I put some steps here for you to follow. An example over there you can follow as well. But as we work through these, right, the first thing we want to do is we want to isolate the radical on one side of the equation. So in number 1, 2 times the square root of x plus 1 equals 4. So we've got to get rid of this 2 that's outside. We got to isolate that radical. Let's say x plus 1, square root of x plus 1 equals 2. And once we've isolated that radical, then we are going to raise both sides to the power of the index. So since this is a square root, the index is 2. So we're going to square both sides, right? So when you square a square root, they just cancel out. And then 2 squared is 4. And once you've done that, then you just solve for x. Boom, done. X equals 3, okay? Now, number 2, same deal. Isolate that radical first. So we've got 4 plus 2 times the square root of x minus 1, right? Just be careful. We are not allowed to add those two things together. Order of operation tells us we cannot do that. So we've got to move them separately. So we're going to subtract this 4 over, since it's positive. 2 times the square root of x minus 1 equals 4. Then we're going to divide out that 2. Right? And again, now since this is a square root, we're going to square both sides. X minus 1 equals 4. And then we can add that 1 over and get x equals 5. All right? Now, number 3. 5 times the cube root of 4x plus 3 equals 15. So same deal, even though it's a cube root, first steps are to isolate that radical. So we got to divide out that 5. We end up with that. Now that we've isolated that radical, we can get rid of it. So we raise both sides to the power of the index. So the index is at 3. So we're going to cube both sides. So when we cube a cube root, they just cancel out. And we have 4x plus 3 equals 3 cubed. 3 times 3 times 3 is 27. And then we just solve. So subtract 3 and divide by 4. Boom, done. Okay? And then same thing here. Nothing outside to move, so we can go ahead and raise both sides, in this case, to the 3rd power, since it's a cube root. 3x minus 4 equals 2 cubed is 8, and then we solve. So add 4 and divide by 3. And we get x equals 4, okay? So those are the more basic of them when there's only one radical, okay? And there's only a variable on one side of the equation. The next ones we're going to look at are when there is only one radical, but we have variables on both sides of the equation, okay? These get a little bit more complicated, but for the most part, the beginning of it's all the same, right? So as we look at these, we still want to isolate the radical on one side, okay? That's the first thing. But then we're going to square both sides. Now the issue becomes, the extra thing here is when we square both sides, the side without the radical, we're going to have to FOIL. And then that's going to leave us with something squared. So then we're going to have to move everything over to one side and factor, and then set each factor equal to 0 and solve, like we solve by factoring like we've been doing, okay? But the issue with these is we also have to check for extraneous solutions. So an extraneous solution is one of the most frustrating things in math because it's a solution that doesn't work. right? So you've done all of your math correctly. You haven't made any mistakes, but somehow you come up with an answer that doesn't work. Real dumb, right? So we've got to check to make sure we don't end up with an answer that doesn't work. So after we find our answers, we got to plug them back in and check them. Okay? So in these, first thing is we're going to square both sides, right? Square root, so we're going to square both sides. So left-hand side just gets rid of that square root. Right-hand side, x minus 2 squared, we have to FOIL. This is where it takes a little bit longer. Right, so when we FOIL, x squared minus 2x plus 4. So we'd have x squared minus 4x plus 4 when we combine those like terms, okay? So now we have something squared, so we're going to end up factoring, so we've got to move everything over to one side in order to factor, right? One side's got to be 0. So x squared, that'd be minus 5x minus 14. Okay, so now as we look to factor this thing, 3 terms, so big X, be multiplying to negative 14 and adding to negative 5 would be negative 7 and positive 2. So as we go through that, right, when we factor this thing, all we're going to have here is 0 equals x minus 7 and then x plus 2, right? And then to solve this, we just set each one of those equal to 0. And we get, add your 7, we get x equals 7. And then subtract 2, we get x equals 2, okay? So there's 2 solutions, but we have to check these 2, okay? So the way we check is we plug them back into the original equation before we squared anything. So if we plug in 7, we go 7 plus 18, square root of that equals 7 minus 2. Plug in 7 for x. So that would give you the square root of 25, and the right-hand side is 5. Square root of 25 is 5. So 5 equals 5. Boom, that one's good. We can keep that one, okay? If we check negative 2, we go negative 2 plus 18, square root of that, equals negative 2 minus 2. So this would be the square root of 16 equals negative 4. So 4 does not equal negative 4. So we just get rid of that one. We say this one's extraneous, right? So we get 2 answers, but we only have one that we can keep, and that's the x equals 7, okay? So that's why we got to check. Okay, sorry about that. So as we go through here, now same deal. With this, square both sides. So that would get rid of that square root over here. So 2x plus 14 equals, and on the right-hand side, we're going to have to FOIL. All right, so when we FOIL, we end up with that. And when we combine those like terms, we get x squared plus 6x plus 9. Okay? Now, same deal. One side's got to be 0. Equal to be x squared plus 4x minus 5. Factor. Multiply to negative 5. Add to 4. And then set each one equal to 0. Okay, so we get negative 5 and positive 1, but again, we have to check. So if we plug these in, we go 2 times negative 5 plus 14. Square root of that equals negative 5 plus 3. So if we work with that negative 2 times -5 is -10 plus 14 is 4. Right? Square root of 4 is 2. So 2 does not equal -2. So we cannot keep -5. That one is extraneous. Okay? For 1, we plug in 1. 2 times 1 is 2 plus 14 is 16. Oh, my bad. Over here, that's plus 3. So equals 4. Square root of 16 is 4. So boom, that one checks out. We can keep that. So we do have a solution of x equals 1. Okay? So that's what we're going with there. Now, last ones are when we have radicals on both sides of the equation. Okay? So in this case, when that happens, what we're going to do is we're just going to raise both sides to the power of the index like we did before. So like in number 7, since they're square roots, we're going to square both sides, right? So when we square that, that cancels out the square root. So that leaves us with 35x equals. What we have to be careful of is this 5 though, okay? So that 5 also has to be squared. And then it gets rid of that square root, so x plus 2. So this gives us 35x equals 5 squared is 25 times x plus 2. So we got to be careful with these because to solve this, we got to distribute that 25. Subtract the 25x and get 10x equals 50. Then we can divide by 10. And then just get x equals 5. Okay? With this guy, same deal, right? We're going to square both sides. Okay? So that's going to get rid of the square root on the left. And then again, we've got to square that 3. It's going to get rid of that square root. So we have 8x plus 6 equals 9x. And we can subtract that 8x over and just get x equals 6. Okay? And then in this last one, same deal, but these are cube roots now. So we're going to cube both sides. That's going to get rid of the cube root on the left. But then that 2, we've got a cube. It's going to get rid of that cube root. 2 cubed is 8. So if we distribute 8x minus 8, and then we solve here, so subtract your x over. Minus 8. Then add that 8. Divide by 7. X is 2. Okay? So that's how we're going to solve radical equations. Okay? So again, make sure the only ones you got to check for extraneous solutions are when there's variables on both sides like that. Okay? The ones where you got to factor, that's where you got to check for extraneous solutions, right? Everything else should be pretty straightforward. So try out the homework. Let us know if you have any questions.